Hey class, in today's lesson we're going to talk about exponential and logarithmic functions, or equations, which is found in section 7-5, part 1 of your book. Our objective is going to be to solve exponential equations. So the vocabulary is any equation that contains an expression of the form below where the exponent includes a variable is an exponential equation. So that form is a equals b raised to the cx. So let's just kind of look at what that means. So it says, what is the solution of the equation below 16 to the 3x equals 8? So again, it's very obvious that our exponent has a variable, it has an x in it. So, but what's nice about this problem is that we have a common base, right? So we've dealt with common bases before. So if you take a look at 16 and 8, they share a common base of 2. So 2 to the what power gives you 16? You should realize that 2 to the 4th gives you 16, and it's still raised to the 3x, equal to 8, which is 2 to the 3rd power. Okay, go ahead and multiply those together, and you should get 2 to the 12x equal to 2 to the 3rd. Get rid of your common bases, and that leaves you with 12x equal to 3. Finally, divide by 12, and x will equal 1/4 or 0.25, your choice. Okay, so again, this only works when you have a common base. Let's take a look at the try. So it says, what is the solution of the equation below? Again, we have a base raised to a power. That power happens to have a variable in it. And then we notice that the two bases, 27 and 81, share a common base of 3. So 3 to the 3rd gives you 27. And 3 to the 4th gives you 81. Multiply here and we get 3 to the 9x equal to 3 to the 4th. The common bases can go away and we're left with 9x equal to 4. Finally, divide by 9 and x equals 4/9. And we can actually just leave that one in fraction form unless you want to find the decimal, and that's fine with me. All right, so then what happens when they have a different base? All right, so when they have a different base, then the only thing that you can apply would be that common base, which is going to be log base 10. So what we would do is we would raise both sides to log base 10, or in other words, just log. So we would say log 15 to the 3x equals log 285. Okay? Moving past that, we then need to take this exponent and move it to the front. So this becomes 3x log 15 equals log of 285. Finally, to solve for x, we would need to divide by 3 log 15. 3 log 15. So then x would equal, and you need to type this into your calculator correctly. For the numerator, that needs to be in parentheses, divided by, in parentheses again, 3, you can either say 3 times or just 3 log 15, close parentheses. And you should get as an answer about, and I shouldn't say equal, about 0. And let's round to the nearest hundred, so they'll give you about 0.70 or 0.7. Okay? All right, let's take a look at our next problem, our try. Again, we notice that there's not a common base here, so the only way to make this work is that we have to use log. So log 5 to the 2x equals log of 130. We'll then take that exponent and move it to the front. So this becomes 2x log 5 equals log 130. Then finally, to get x by itself, we would divide by 2 log 5. So x is going to equal, and again, if you type this into your calculator correctly, you should get about 1.51. I should say about 1.51. All right, at this point, the lesson is done for my general Algebra 2 students. If you're pre-AP, let's take a look at the next problem. So it says, what is the solution of the equation below? Use a graphing calculator. All right, so we could do this by hand, right? We could still, and specifically they want us to use a graph or a table. I'm honestly going to leave that up to you, however you want to solve it if you were taking a test. However, if you would like to see how this is done, then let's just kind of follow. So what we have is 4 to the 3x equal to 6,000. We've kind of been doing this for quite a while now. What we would do is subtract 6,000 on both sides. And what we would type into the y1 section of our calculator is 4 to the 3x minus 6,000. So if we type that in, four to the 3x minus 6,000. We would then do second trace, left bound and right bound. And after doing that, you should get, as an x value, about 2.09. And again, you could find this the exact same way by just doing the log. So again, if it's a little difficult for you to find it on a calculator using a graph, and that's fine. Just choose one and make it something that you can own. All right, let's look at the try. So again, I know we're going to subtract 800. So this will be y1 equals 7 to the 4x minus 800. After you type that in, you'll do second trace, go to 0, and then do left bound, right bound. And on this one, you should get about, x is about 0.86 if I round to nearest hundredth. Finally, the last one, I'm going to subtract 400. And we should get y1 equal to 5.2 to the 3x minus 400. Again, we need to type that in. After you do second trace and 0, do left bound and right bound. You should get a value where x is about 1.21. And guys, that is it. So once again, if you have any questions, please be sure to come see me for tutoring.